Let's look at an example with two variables. We have the scores on a test for 10 students, and we also know the time that they spent studying. In order to read this chart, you should focus on the grade on the first column and on the time in hours that they studied on the second. So the first student, he studied 13 hours and his score was 89 out of 100. The second student, he got 90 and he studied 15 hours, and so on. We would like to see if there is a correlation between those students, and to also see if there is a kind of an equation that we can consider in order to see if how the time that somebody studies relates to the score of the test. How do we do that? Okay, let's see this together. The first thing that we want to do is to actually see it graphically, have a visual representation of what's happening. Select the two columns and click on the graph, fit the Y for X. Okay, the first thing that we want to make sure that we understand is what is the independent variable. The independent variable is the time that the student spent. We assume, of course, that there is some relation between the time that he spent studying with the score of the test. So the dependent variable, or Y now, will be the score of the test. We click on the YX up here, the fit of Y by X. We come here and we can select the first one, score in test 1, that is going to be the response variable, and we enter it here. We assume that its time studying is the X, or independent variable, and we enter it here. We want a bivariate model, and we click OK. What we get right here is a scatter plot. A scatter plot that shows us the relation of each one of the points. Each one of those points refers to, on the x-axis you see the time that he spent studying, and on the y-axis you see his score. So this specific student is the student that he got 65 on his score result, so it's the 10th student, and he spent studying 9 hours. Okay, so this is the first thing that we need to do, and it's the scatter plot that we receive if we put those values together on the Cartesian plane. The next thing that we would like to do is to go further in our analysis and actually do a fit model. Click on the fit model. This is going to allow you to run a regression. What do we have here now? We have the Y, that is going to be the response variable, that is the score in the test. And the only variable that we have available for each one of the students that can affect his scores is the time studying. So we add that to the mod effect, meaning those variables that affect the actual scoring. We want to run the standard least squares. It's the method that gives us the regression. There are many different types of regressions that we can run. We choose this. We don't care about checking the effect leverage. We click Run. Now this is the information that we get. The first thing that I want you to look at right here is the first plot. This is the regression plot. You don't care about the leverage plot or the predicted plot. You focus only on the first one, the regression plot. As you can see, it gives you the scatter plot that you already have, along with the line. The red line that you see right here is actually nothing else than the regression line. The regression line, but down here it gives you much more information. The R-square, where the R-square is nothing else than the square of the correlation coefficient. It's 0.66. It gives you also the entire model for running this regression. Information that we are going to discuss later in our course. Now, you need to focus on the parameter estimates that gives you the intercept, and it also gives you the time studying. These two variables are going to be the ones that they will show you what will be the line that predicts this information. The first one, intercept, is going to be the b in your equation. The second one, 3.49, is going to be actually the slope of your equation. So by looking at these two numbers, you can create the equation that is 3.49x plus 38.52.